What you've just heard was a piece involving metric modulation. It was written by great drummer and educator Gary Chaffee in his book Rhythm and Meter Patterns. Metric modulation is a great tool to create a feeling of a different meter and/or a different tempo. Imagine that you play one bar ending with 8-note triplets in 84 BPM. Let's call it bar 1. Then you play bar 2, which has 16th notes, but their speed should be the speed of the triplets from bar 1, so that the listener will not notice the difference. Therefore, these 16ths are slower than the 16ths you would have in 84 BPM. There are two ways of dealing with this situation. The first is that you adjust the tempo of bar 2 so that its 16ths blend with the triplets from bar 1. How? Well, the blending will occur if the space between three consecutive 16th notes is the same as the space between three notes from an 8-note triplet. An 8-note triplet is equal to 1/4 note, which is one metronome beat. Now we need our new beat to be based on 4 such 8 notes from a triplet, because there must be 4 notes in a group of 16ths. 4 8 notes from a triplet are 4/3 of a beat, or approximately 1.333334 of a beat. To get our new tempo for bar 2, we divide 84 BPM by 1.333334 and get 63 BPM. So, 84 BPM for bar 1 and 63 BPM for bar 2. Let's listen to both bars. Since we deal with repeating decimals, we can't set up an absolutely precise tempo, but the difference is hard to notice. That way, we can adjust the tempo for any modulation. Say, in bar 7 of Gary Chaffee's study, the speed of 16th note sextuplets become the speed of usual 16ths. We take 4 notes from a sextuplet, which are 4/6, which equals 2/3 or 0.666667 of a beat. 84 BPM divided by 0.666667 equals 126 BPM. So, I just programmed a special click track with all the necessary tempo changes to perform the whole study of Gary Chaffee. Let's listen to it one more time. But there is another way, where it really feels like a modulation, rather than playing in changing tempos. What if we just leave the metronome at 84 BPM? The piece as it is heard by the listener will remain the same, but technically we will step into a new coordinate system. Let's look at the study. Bar 1 remains the same. Bar 2, since it has modulation, will look like this, because everything that happens in this study is now based on 84 BPM tempo. The scary stuff happens in bar 3, since it has quintuplets, and their placement will differ from the initial one. A 16th note quintuplet is equal to a group of 4 16th notes, and our 4 16th notes are now 4 notes of an 8-note triplet. So, we need to fill the 5 notes of a quintuplet into one 8-note triplet plus one more note, which is taken from the next triplet. To do this, we divide these 4 triplet notes into quintuplets, thus getting what is called a nested tuplet. In these 20 notes, we pick every fourth and leave the others as rests. That's it. We have fit 5 notes of a quintuplet into one 8-note triplet plus one more note. Basically, this is how a 5/4 polyrhythm is created. But here, I have no idea how to call this. 5/4/3 tuplet? To give you a glimpse, this is how the whole bar looks in an 84 BPM coordinate system. Well, not the whole, because we have to move the last note to the next bar. Otherwise, the time signature would be something like 9/4 plus one note from an 8-note triplet. In this manner, it's possible to recalculate the notation for the rest of the piece. But instead of performing such a risky procedure, let's listen to the piece with constant tempo 84 BPM. Something interesting happens towards the end. So, as you might guess, in a certain point, bar 9 to be precise, the two coordinate systems come together, just like 2 meters would do in a polymeter case, while the notation becomes identical. Funny enough, it's not that hard to play this piece with a constant tempo, much easier than to write down.